Hello, everyone. This is Thomas. I'm a developer of the Tanzu Application Catalog team. Today I'm going to show you how the Tanzu Application Catalog product works with air gap support. Specifically, we will see how to use the chart syncer tool, which is an open source tool that we have developed to help with this problem. So before going into the details of chart syncers and this air gap problem, let me briefly explain what Tanzu Application Catalog is. And this is basically an enterprise version of the Vietnamese Application Catalog. And it's designed to enable secure usage of open source software in production environments. It is delivered as a cloud service that enables customers to build their own private catalog of custom package open source application components that are continuously maintained and verifiably tested for use in production environment. What we will show you in this demo, is basically how to use this chart syncer tool to replicate the artifact produced by Tanzu Application Catalog, basically container images and Helm charts, how to replicate it from the registry where Tanzu Application Catalog is pushing this artifact to your air gap registry. So what's the status of the artifact's relocation? Containers are easy to distribute. There are already existing tools like Docker or Crane or Scopio, and with all of these tools, you have options to basically move one container image from one registry to another, and you can also make them to support air gap environments by just downloading those container images to your local computer in the form of a tarball or similar. Then you can move that tarball to your air gap environment. And finally, with a complementary command, you can push those container images that are bundled to the air gap registry. And this is simple because the container images hasn't changed between registries. It's exactly the same. But this is not the case for Helm charts. Basically because the Helm charts contain references to the registry where they are located. So they have references to other Helm charts and they have references to container images. And you can't simply download one Helm chart from one registry, move it to the air gap environment and push it, because if you do that, you will be pulling or try to pull the container images from a different registry. And if you are in a real air gap environment, you won't be able to pull those images. This is what I was mentioning before, that the Helm charts contain references to the registry where the Docker images are located. And in this case, this is a values.yaml file from a Helm chart of the Vietnamese repository. So if you want to replicate this Helm chart, you need to ensure that you have modified these source files and that this registry and repository points to your new registry. So how do we do this with chart syncer? How do we support these air gap environments with chart syncers and Tanzu Application Catalog registry? So we have here on the left side this source registry, which it's basically the registry that Tanzu Application Catalog is populating continuously. This is where Tanzu Application Catalog is delivering all those container images, all those Helm charts in a regular way. Each time there is any update or any CVE that should be fixed, this is the registry where Tanzu Application Catalog is pushing all those artifacts. So we have a first step, which is prepare the bundles. We are going to prepare first a tarball with all the components needed in that Helm chart to be relocated. And this basically includes the Helm chart, all the container images that are referenced by that Helm chart, and additional metadata produced by Tanzu Application Catalog, like the signature, the cosigned signature, so you can verify the source of these container images, additional metadata like SPDX, test results, CV scanning, etc. Once we have these bundles locally, we will need to manually copy all those tarbals. They are basically target set files, so you can just copy to a USB stick or any other method that you prefer. And you need to copy them to your air gap environment, which is what we see here in the right side of the image. And finally, there is a third step that is complementary to the first one, and we will need to load all these bundles to the new air gap registry. And in this step, ChargeSyncer will modify the Helm chart so you can consume it properly from this registry. So let's talk a bit about ChargeSyncer tool. What is it's basically an open source tool that it's developed by the Tanzu Application Catalog team, and we have made it basically for this specific purpose to help with air gap environments. Also, you can use it also to directly move from one registry to another without the need of download those local bundles. It has some options to configure how it runs. So you can synchronize full registries. You can only synchronize the latest version of a specific Helm chart. You can synchronize from a specific date, etc. What ChargeSyncer does is rewrite to the Helm charts values.yaml files and other files that are pointing to the registry, and basically it ensures that it contains the final registry, the target registry, which is the registry where you will be consuming these Helm charts. And also, a nice feature is that it not only relocates container images and Helm charts, but also related artifacts produced by Tanzu Application Catalog, like the container signatures and the metadata. And with that, I'm going to start with a simple demo. I'm going to use this registry. This demo Go Harbor registry is useful for testing purposes because you can have ephemeral registry that you can create today and tomorrow they will be erased. So I'm going to use these two projects, demo source and demo target. Demo source, it's already populated with some Helm charts and container images. You can see how we have the Minio and the etcd Helm charts, and we have the containers for Minio client, or Shell and etcd, which are the container images used by these two Helm charts. And I also have this demo target that basically is empty. So we are going to try to replicate the container images and the Helm chart from this demo source registry to this demo target as if they were disconnected, as if demo target was an air gap environment. So for that, we are going to run the first step of the air gap bundle image that we saw during the presentation. And I'm going to execute ChargeSyncer with this config file that I'm going to explain. So first, I want to download all the Helm charts from this source repository, which is with the one that I saw before in the Harbor UI. I'm going to download all the Helm charts from the demo source charts Debian 11 folder. I'm specifying the credentials for the Helm charts and for the containers. And I'm going to get them in this local folder. This is basically the path where I am right now. And I have a local charts folder, which is empty right now. So if I execute ChargeSyncer and I sync using this config file, it will detect right now that there are a couple of charts out of sync. Here you can see that it will be iterating over two different charts. The first one, it's the etcd one. And right now, this is downloading the Helm chart. It has uncompressed the Helm chart. It has detected the container images that are used in that Helm chart, and it's also downloaded them. So for example, here is right now it was downloading the host shell. It should have also downloaded the etcd one. And soon it will start with the second chart. Yeah, it says that all images have been pulled successfully. And finally, it is compressing the bundle. And this is the final location, which is the path that I use in my config file. You can see that it's chart syncer local charts. And that one is in the local, yeah, in the temp file. And now is iterating over the second chart. Something to mention is that you can see here that it was specifying the architecture. So if the container image is multi-architecture, it will pull both versions, in this case, the AMD and the ALM. So we have all of them. And if you are interested, you can also configure this in Chart Syncer in the case that you are only interested in one specific architecture. So as in the case of etcd, for Minio, it has downloaded the Helm chart and it has pulled all the images, and I have downloaded finally the target sheet. And if we see again the content of the local charts path, we can see that we have one package, one tarball for each of these charts. Right now, this tarballs contains everything related to this chart. It contains the Helm chart, it contains all the container images, and it contains also the container signatures and all the metadata related to those container images. So we don't have nothing yet in the demo target. Right now, we need to run the second step of the air-gap environment process, which is we will need to copy these tarballs to an environment, to the air-gap environment. Since I'm mocking this air-gap environment, I'm going to assume that I have already copied these tarballs, and this is the target path in the air-gap environment. So the only missing step is the third one, which is now we will need to take these local charts from here, and we need to push them to the target registry. And for that, we have a complementary configuration file, which is I'm going to use as a source this path, this local path that has all these tarballs. And as a target, right now you can see how I am using the other registry that I showed you in the demo Go Harbor.io registry, the demo target, and I'm also specifying the path for the containers and also the credentials. So let's execute it now. Right now, this is unwrapping, this is uncompressing this tarball. It is relocating it. At this point, we already know the target registry, so Chart Syncer is doing the proper modifications in the Helm charts and is pushing all the images that were previously downloaded. So in this case, the etcd and the OSL one, and is doing the same for Minio. You can see here also that it's pushing not only the container images, but also the signature and the metadata. And soon this will be finished, okay? So right now we have all the charts synced successfully. Let's take a look to the registry. This is demo target, and here we see how we have two charts. We have Minio and we have etcd, and we have the containers for them. So for example, we can take a look to the values.yaml files of this Minio chart just to see how it has been properly updated. And here you can see how the registry, yes, is still demo Go Harbor.io, but the repository has changed. In the source, this was demo source, and right now, after Chart Syncer has relocated this chart, it's demo target. Another thing to mention is, for example, let's take a look at this Minio container, is that it has relocated the metadata, which is this artifact that you see here. And it has also relocated the signature, as you can see here. So for example, we can verify using this cosine verify. We are providing the public key of Tanzu Application Catalog, which is in this well-known URL. And here I'm specifying, for example, the Minio client image. And this is a successful validation because the exit code is 0. Otherwise, you will see an error about unmatching signatures. So as a final step, now let's install a Helm chart from this air gap registry, from this final registry, from the target one. So for example, let's install Minio, Helm install, we call it Minio, and I'm taking this from the registry that I use as a target, is demo target. This was the version that I have replicated. And since this is a private registry, I have to use an image pool secret so we can pull the image. This, I have already created this before, but this is not related to the demo. So I'm installing right now the Helm chart. This is, okay, it's already running. So let's see if we can access to the UI just to verify that it's properly working. I'm going to copy the admin password. I'm going to expose the UI, which is here. And here it is. We can see that we have this Minio application. It's properly running and with proper credentials. So that was basically all that I wanted to show. Just as a summary, we have used chart syncer tool to replicate Helm charts and container images and OCI metadata and container signatures from a registry, the source registry, which is where Tanzu Application Catalog is delivering all those artifacts. And we are basically using chart syncers in 2 steps. One, to download all those bundles to a local folder. And then in the air-gap environment, we are using again chart syncer to load those local bundles to the final registry. And just at the end, we have seen that we can still verify the container images with the same cosine key, and we can also deploy properly the Helm chart that has been successfully modified. That's all. If you have any issue with chart syncer, feel free to open an issue in the GitHub repo. Thank you.